5, 4, 3.
You're listening to Coding Blocks, episode 75. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app.
And check us out at codingblocks.net where you can find show notes, examples, discussion, and a lot more.
Send your feedback, questions, and rants to comments at codingblocks.net. Follow us on Twitter at codingblocks or head to www.codingblocks.net and find all our social links there at the top of the page. Blast from the past.
I was wondering if you were going to do that again.
Yeah.
Because we hadn't heard that in a while.
It's been a while. So with that, I'm Alan Underwood.
I'm Joe Zach.
And I'm Michael Outlaw.
All right. So before we get into the show, which this one's going to be about screaming architecture and the various different business rules and entities involved in there, first, we like to go over what we very much appreciate, and that is the reviews that we've gotten.
Yep. And so for this episode from iTunes, we have, first of all, these are going to be some great names. So let me just go ahead and give you that. Prepare yourself for these amazing names. Tillman32, Satisfied Photo Printer, Cyclomatic Double Complexity, and Portuguese.
Those are awesome.
That's
and apparently
fantastic.
I have Stitcher. I didn't even know that. So I've got Sticks, Edward Dunn, and Rosengren.
Yep. Very nice.
Yes. Thank you all. Go ahead. Were you about to do one? I forgot I put this thing in here.
Well, I was gonna mention your thing here. So we had a previous tip of the week. Someone brought to our attention that it's SQL Server Management Studio 2017 only. And you want to explain that, Alan? I forget exactly what it was.
Yeah, so in the last episode's tip of the week, I said, hey, if you open up the output view and you go and you show Object Explorer in that drop down, then it would show you all the cool stuff that's happening when you expand nodes in the left side for navigating, your databases, your tables, all that kind of stuff. Well, and now I can't remember who it was. Man, that's terrible. At any rate, it was brought up that it wasn't working, and what it boils down to is he had SSMS for 2015 installed. Apparently it did not work there. So in order for this tip to work, install SQL Server Management Studio 2017. And the cool part is it's free, so you can go download it from Microsoft. And they are really good about their Management Studio products being backward compatible. So chances are you can download that thing and get all the cool new features, and it'll still work with, heaven forbid you're still working on SQL Server, 2008 or something, but, or I don't even, was there a 2000? I don't even remember what the versions are anymore, but yeah, it'll probably still work with all that stuff. So, there you go.
Yeah, big thanks to Jerry for pointing that out for us.
Jerry, thank you. Man.
Yeah, hey, and I've got a talk coming up here at Orlando Code Camp, and that's on March 17th. So if you are in the Central Florida area or feel like making a drive, you should stop by, say hi, go to my talk, throw stuff. I did a little preview last week, and nothing bad happened. So I'm sure, knock on wood, everything's going to be fine coming up.
Is that the measurement of success if nothing bad happens?
Yeah, not falling over. I mean, yeah, I left my laptop charger there, and anyway, that's a whole big shebang.
That's a $70 mistake. But,
I know. And I got it back. After I bought another one.
Well, now you got two. So bonus.
Yes.
Yep. That's true. Hey, also, speaking of bonus, our bud Jason from Unity 3D College is launching his master course, and he's selling tickets from the February 19th to Sunday the 25th. And then he's going to start the course. And if you've ever watched if you're interested in like Unity game programming type stuff, and if you've ever watched any videos on YouTube, you've probably seen some of his videos. He puts out excellent videos. They're really popular. I've watched a few, like not even realizing it was him. And they're really awesome. And we're going to be giving away, doing a little giveaway here on the mailing list. So if you're not on the mailing list and you're interested in this giveaway or other giveaways, you should sign up for it because we're going to be doing this real soon. So basically, right after this episode launches, we're going to blast that out. So if you're interested, make sure you are on that list and checking your email. So that's going to go quickly. And then we're going to have a JetBrains thing coming up right afterwards. So good time to join the mailing list.
Hey, yeah, I was going to add to that. Like, if you're not already part of the mailing list, you really should join up because we pretty much only use it to give out stuff.
Yeah, that's pretty much it. Hey, but also I did want to point out though, you mentioned that Jason, this course isn't like, hey, sign up for a course and and you get to watch some videos. This is a very highly interactive course, correct?
Yeah, this is his master course. He calls it. It's very hands-on. It's not like you're buying, access to like a couple Plurals type videos or anything like that. This is very much more a hands-on approach where you have to actually kind of work and interact with him as he shows you the ropes. And I mean, if you're interested, like, just go check out his videos on Unity 3D College. We'll have a link here. They're also up on YouTube. Fantastic material. I mean, you get to see pretty much who exactly you're going to be dealing with here. And if you are interested in game development or Unity, I mean, it's just an awesome opportunity.
Cool. Excellent. And what we got next?
Also, hey, speaking of more giveaways, we're going to be giving away a book again on this episode. So make sure you leave a comment on this episode. It's going to be codingblocks.net/episode 75, or just go to the website. You can find it. And drop a comment on the episode. Say whatever you want. And we will enter you in a drawing to win a book. And we'll send you the physical or the ebook. Just leave a comment.
Yep, excellent. And there were some excellent comments on this previous episode on 74 as well. So go up there, read those. I need to respond to a few of those. Also, if you're interested in Pluralsight or anything like that, and you'd like to help the show out, head to codingblocks.net/resources. We have links up there for the books and Pluralsight and various different things that we like. So if you want to give back by just getting what you were going to get anyways, that's a great way to do it. Also, we forget to put this in the show every time, but if you are interested in stickers and improving the performance of your laptop or whatever you slap those things on, head to codingblocks.net/swag and send us a self-addressed stamped envelope.
Stomped envelope.
You can stomp on it too. Yes, put some footprints on there. We will gladly take it, and we will ship you out some stickers. So do that. And I think that is pretty much it, guys.
All right.
Let's get
into the meat of the show here. And let's start by talking about the policy and level.
All right, and I really like this chapter. As I think I say that every time, but I particularly I liked the idea of the word policy. It's kind of funny because I think this is a great word for kind of describing what a computer program is. Right? It's a policy that you pass a bunch of inputs and you get a bunch of outputs from, and that's something like that. I don't really see that word very often in code. And I'm glad. Like I feel like I've seen the word code in code more than I've seen policy. I've seen the word core for sure. I've seen the word manager a lot more often, but policy is a good word for, meaning like a rule or a description of behavior.
I mean, you probably see code in your code when you're using Visual Studio Code.
Yeah.
As you code.
Folder name code in your code. And so you put some of your code.
Isn't it funny? We've changed that to SRC so that it's not code, even though it's code. Yeah, whatever.
I just name all my helper classes code.
That's helpful.
It's not wrong.
So they go on to point out, right, this whole notion of code is basically policies for how things are supposed to work, the expectations of the inputs and the outputs. And most systems are made up of multiple sets of these policies, which makes a lot of sense, right? Like your application does many things.
So what's a policy? Can you give me an example?
Business rules, formatting, ETL. If you've never heard of ETL, that's extract, transform, and load. So that's basically when you're moving data from one place to another and scrubbing it and cleaning it, all that. Any of those type things that go in your application.
Yeah, my mind immediately went to business rules, but like formatting absolutely is, like whether it's a PDF or HTML, or even like if we're talking about HTML, just the way that it's formatted, the various rules that we've kind of defined to make this thing look how it's supposed to look. Like those are all examples of policy.
I mean, think about a UPS label that you print out that you get, right? How that thing prints out, the size that it's got to be and all that, that's a very specific type thing. And that is part of the policy. This thing needs to adhere to a particular standard. So yeah, all these things, they go into it.
Yeah, and like we talked about in some of the previous chapters, policies that change for the same reason should be grouped into the same components and vice versa. Do you remember which one that was? Was that the... There's S&P in there somewhere.
SRP, single responsibility.
No, the CCP, right?
Closed caption principle?
No,
caption. That's what
I've actually got that down here.
It's closed caption for people.
We should make some little note cards here.
Ah, man. Anyways, SRP is single responsibility principle, and the common closure principle, I believe, is what it is.
There we go.
You're right, yes.
That was close.
So yeah, I mean, it makes sense, right? Like you should keep things together that are supposed to change together. We've talked about that previously. But the goal that they point out here is to create an acyclic dependency graph where the items with similar policies are at the same level and the dependencies are at the edges. And that sounds that's very vague sounding. Would you agree?
I think at this point in the book it is.
Yeah.
In a couple chapters, which we're going to get into,
Yep.
It's going to start to some of this is going to start to come together and make more sense. But when we're talking about dependencies at the edges, it's still like, what edge? What are we talking about? And what's the level?
Yes.
Like we're talking about policy and level. And Joe asked like, hey, what's a policy? But we haven't even described like, what's a level?
Right.
But we're already talking about things at the same level.
Yep. And that's the thing. So right now, if this is confusing, it should be. Hopefully the details will iron that out here in a minute. So we're going to keep pressing forward and help this out.
And we've talked before about kind of drawing directional graphs between dependencies. And we kind of take a different slant on that same kind of approach here. And we talk about the direction of that dependency flowing based on the level of the component. And this is where they actually give us a definition of what they mean by level here. And they say that level is the distance from the inputs and outputs. So your little class that reads input from the command line, is that low level or high level? I guess that would be low level.
That's the low level. So basically what they talk about is when you have your low level inputs and outputs, those are the things that can change a lot, right? And so that's your lower level component.
Okay, and your thing that say like does the math or does the processing, it has your business logic, stuff like that. That stuff should be at a higher level because it's further from the input and output. It just does the syncing, it passes to someone else, and that someone else is responsible for routing it where it needs to go.
Okay, I'm glad that you guys are confused about the higher level, low level too, because I always get those backwards as well. And in fact, as you said it, I was like, wait a minute. No, the higher level
is your business component.
No. The higher level stuff would be like he mentioned command line, so that mentions some kind of a UI, right? That's some kind of an interaction. So that would be higher level. The lower level details are the policies.
Yeah.
The further the policy is from the inputs and outputs, the higher the level.
Yes.
So it's like it means more abstract.
Yes. You want your
well, that's going to get really confusing then when we get into this upcoming chapter, because it specifically says the further you go, the higher level the software becomes.
Right, and that means the more abstract, the farther it is from the actual like input and output of the system.
I guess when I was thinking higher level, I was thinking about reading from in to out.
I always have a hard time with like binary choices like this, especially not. So like if you put a not in an if statement, like you've stumped me.
Yeah.
I'm going to be there for a while.
You know what? That brings up a thing of mine that I am actually very passionate about doing. If I'm checking for a not of something, I don't do not something because like you said, it's confusing. I'll actually put equal false. I know that's not necessary, but it's very explicit. Like if this is not true, then it's just, I think it calls it out easier. It's easier for people to see that equal false than it is an exclamation at the beginning of it. I don't know how you guys feel about it, but
I think it depends on the variable name. And we're way off topic, but I think it depends on the variable name. Because if the variable name that you're trying to not, if it was like, let's say you had a variable name that was is ready, and you want to say is ready equal false, that would read weird. It would read better if it was if not is ready. To me, reads nice. Does that make sense? So it very much depends on the name of the property or variable or whatever that thing is, that condition that you're trying to not.
That's such, it's still to me like, I don't know. I am hyper crazy about this. Like I used to do not then whatever all the time. And at some point I think I overlooked one because I don't even think it had anything to do with the naming of the variable, but the exclamation just kind of disappeared in with the flow of the text. Mm-hmm. And so I made the mistake and I'm like, never again.
Right.
So I don't know. It's
I definitely understand where you're coming from with it disappearing. And so that is a strong case for going ahead and being explicit about it. But sometimes when I have ran into those situations where like I thought that it didn't read right, then I looked at that and thought, well, that's an opportunity that tells me that the way I'm using this property or variable or method doesn't read well with the code.
Right.
And so I should give it a better name.
If it doesn't sound right when you say it.
Yeah. I wanted to read more grammatically correct.
While we were doing all this, I wanted to pull back up the diagram so that I could at least, talk about it. Yes. So the higher level is what we said. The higher level is the more abstract, the things that change less frequently, and the lower level are the things that could change all the time. So that's where they go with that. I wanted to make sure that we were all on the same page there.
And speaking of the same page, I do want to mention that true and false is hard, but what's way harder is less than or greater, especially if there's an equal sign in there anywhere. And now you throw date diff on top, and holy cow, man, I got to do some examples. Like I got to work out a paper. Like, okay, date diff, this is the right order, and this is the way the sign's going. Please, no one ever touch it again.
Okay, so higher level, then lower level would be the input.
Correct. And
higher level. Okay.
Yeah, and we'll dive into this a little bit more. I think it'll all start making a little bit more sense here in a second. So let's
maybe not
press on, hopefully. So actually, the very next bullet point we have here, the further the policy is from the inputs and the outputs, the higher the level. That's the very next line we have. So yes, the further you get away from the things that are taking data in from a UI or some sort of file system or whatever it is, the more abstract it should become.
Yeah, so your web service endpoints, low.
Yes.
Your core library, high.
Yes. Well, there shouldn't be a core library, maybe.
No, it's called code.
Code, yeah. The code library.
Code helpers. Helpers code.
All right, so one thing that's interesting, and this is where not having the book is going to be kind of detrimental, and we're obviously not going to copy and paste pictures out of the book because we're not trying to, get any lawsuits or anything. But in the diagram that they have on here, they show that the dependencies are pointing in one direction, but then the source code dependencies go in the other direction. And they wanted to call that out. Like, they don't necessarily have to flow the same way.
Right, but how can you have, say, a core library that depends on lower level things? Like, how can you do that without touching those lower levels?
Man, I think this is jumping way ahead. It's
That's probably
inversion of control, right?
Yeah, I mean, that's the answer to like everything in this book so far.
It really is, and it's kind of frustrating. And just for those out there listening that have no clue what this is, like, it all sounds great, right? Like, when we talk about a lot of this stuff, it sounds great on paper. When you say, oh, well, just inversion of control or dependency inversion or inject the dependencies. If you've never seen it, then it just doesn't make sense. And so I am going to try and put together some videos that will be like a series of, this is how you typically start an app. And if you wanted to invert that control flow, this is how you do it. So I am going to put some videos together that will hopefully make a lot of this stuff make more sense, because if you've never seen it, it doesn't. Anyways, so back to this. So they're saying the data flow can go one way, but the source code dependencies can go the other way. And that all has to do with dependency inversion. And we'll talk more about that in a little while. And this is where it's kind of interesting. Dependencies should be decoupled from the data flow, but coupled to the level.
Right. So dependencies you always point, the dependencies should be decoupled from the data flow, which means that if you got a higher level item, like the example of our core library, it should not be coupled to those lower level items. So your core library should not be touching that scanner, should not be touching that web service. There should be a level of indirection there with like an interface or some sort of layer boundary.
So your entity framework layer should know about how to talk to SQL Server, right? But the layer that's higher than that knows how to calculate tax on an order shouldn't know or care about that dependency. So data, you can flow data from that entity framework layer to that higher level so that it can do that calculation. So that's the data flow, but the dependency is coupled to the SQL Server dependency is coupled to the same level that entity framework is on.
Right.
So
data is going up,
picture
but the dependency is not coming down.
Right. So picture you have an order tax calculator that is at the highest level.
Mm-hmm.
And let's say a level below that is the entity framework layer. And so it might know how to, and there realistically, there'd probably be something in between there. But, the point is that whatever is getting that data, it's massaging that data and putting it into some kind of package in order to send it up to the higher level. The higher level doesn't know about that dependency.
Correct. So we've got SQL Server at the bottom is sending data up to Entity Framework, is sending data up to the calculator. But what we are saying too is that calculator knows nothing about Entity Framework, and it knows nothing about SQL Server. So that's why we're saying the data can flow one way and the dependencies don't necessarily go down that same path.
And this is why I was thinking, when I made the comment about there might be something in between, realistically, because between that entity framework layer and that calculator layer, because if we were going back to our domain-driven design conversations, right, you might have something in between there that's, the entity framework layer, that level is one thing, but you have another object in between it that's actually using that data. And that might package the data up to send it to the higher level calculator to get that result.
Right.
And the book here has a really nice example of an encryption library. And at the kind of the top of this higher level, this little hierarchy here, we've got an actual library that does the encrypting, and it's called Encrypt. And it has a dependency on two interfaces, the character reader and the character writer. And because of these interfaces, you can swap in things like, you could do it from the command line, you could do it from, a network connection. You can do all sorts of stuff in and all sorts of stuff out. You can print the encryption results to screen. You can send it somewhere. You can do whatever you want because the encryption library is at the same level as the character reader and the character writer. And the encryption knows about the reader and the writer interfaces. On the lower level, the lowest level, we've got a console reader and a console writer. These things that are just deal with like a terminal window, reading in input and spitting it out to screen. And the console reader and the console writer both are aware of those interfaces that they implement. They have to be. But they are at a different level.
So what he's describing, to paint the picture again, encryption thing is at the top. That's your high-level component. In the middle, you have these interfaces that are your character readers and writers that both the encryption component at the top knows about these two interfaces, character reader and writer, and the console reader and writer low-level components at the bottom also are aware of those interfaces. So all that's in between the encryption layer and the console reader and writer are these interfaces for character reader and writer. And that's your abstraction. And that's how you can add this misdirection or this inversion, right?
And if we were to break this up into components for some reason, if we obviously this is a trivial example here, but in this case, you would have your encryption library, and inside that component, you would have the definition for that character reader, and you'd have that definition for the character writer. And it's really important that you have that abstraction on that side of the boundary so that you can plug in any sort of readers and writers that you want to at that level. If it were reversed, where you had the interfaces for the character reader and character writer in the same library as the reader and the writer, then you would be taking a dependency from Encrypt onto that library. And that sounds kind of like a trivial kind of thing, but in this case, it's a very obvious decision to make. I think anyone would make that decision. But that's the kind of stuff that can trip you up if you're doing something where it's not as obvious. And so it's really important to pay attention to that level and make sure that you're flowing in the right direction.
Yep.
Yeah, I mean, we've talked about this before. We've talked about similar kind of concepts like this. And I felt like this book or these chapters answered some questions that we've had before, where it's like, well, where do I put some of these things, right? Like, where do I put my interfaces? Do I put them in a separate project, or where do I put some of these DTOs? Do I have a separate namespace for those? And if I understood these right, these chapters right, the answer is that they should be next to within their level. They should be next to that same level, right? So in that example that you were just describing, Joe, the encrypt is the highest level policy, right? But those interfaces for the reader and writer, they are in that same level with that. I mean, they're below it necessarily, in terms of like drawing, but they would be in the same thing.
I don't know that
because the encrypt would have to know how to read. It'd have to be able to read something, right?
So you could, I think this one's kind of open to interpretation a little bit. So here's the thing. You could do it both ways. You could put that interface up there with that encryption component, right? You could put it up there and then it would know how to talk back and forth to these things. But the part to me that's interesting is in this little circle, right? Encrypt is pointing down to these two interfaces, and the reader and writer are pointing up to those two interfaces. So in my mind, I would almost say make that a separate, I don't know, maybe a project, maybe separate project with just those interfaces defined in it, and then both the encrypt would reference that interface project, and the console reader and writers would also reference that interface project.
Let me say it this a different way, and let's not care about the projects for a moment.
Okay.
Let's say that I was going to ship you a DLL that does encryption, right? That DLL or jar file, or however I choose to package this thing up, this gem, this Ruby gem, you're going to have, I'm going to need to know how to read and write data from you and back to you, right? So I'm going to supply you with like, hey, here's the interface that I expect that you are going to provide an implementation of. You're going to provide a concrete implementation of this interface. And that is what I'm going to use to do my reading and what I'm going to use my writing back out to. So they're packaged up in my same package.
Right.
Doesn't matter what the project is.
Okay. Yeah.
And so that's what I'm getting at.
Okay.
Is that when we've talked about these kind of things in the past, like, hey, where do I put this stuff? Right. And these chapters, and it's going to come up again later when we get into DTOs, and we kind of hinted on it a moment ago when we talked about data flow, is that it kind of says that it needs to be next to the, it needs to be within the level that it's trying to support.
Whatever
like that interface or DTO needs to be at that level.
Right. Yeah.
So
go ahead.
I was going to say, check this out. So if you're trying to decide whether something should be in the same namespace or the same component, one question you can ask yourself is that, are these classes at the same distance from the input and output? If the answer is yes, then you could put them together possibly. Then there's other considerations. So it's still a maybe, but if they're not at the same level, then your answer is no, they should be separated. But furthermore, if you can't tell if two classes are at the same level, then that's an indication that you've got levels mixed into your code and you've got business logic tied in with your inputs and outputs. And that's something that you need to take a look at. So it's an indicator of another sort of problem that you've got going on there.
That's interesting.
Okay, so then how would that apply then to this example with the char reader and char writer?
So if I had a single class that got input from the screen, encrypted it, and spit it out all in one class, that would be an area where I've got two different levels. I've got the input output, I've got my logic.
Right, but what I'm saying is, like, going back to the example that he describes in the book, right? If the encrypt functionality is the highest level of the application, right? What is the distance from the input and output of those interfaces? Is it the same as the encrypt, or is it closer to? Because the encrypt definitely needs to know how to use those, right?
Yes, so I would say that they're at the same level.
As encrypt?
Yeah, I would say so. I mean, the picture definitely has them drawn in a hierarchy, so I'm kind of questioning whether that was the intent or not. But to me, they're at the same distance. They're both relying on some sort of input and output, but it's completely abstracted as to how it gets in there. So I don't think there's any difference between encrypt saying, hey, I know about a character reader, or a character reader saying, hey, I know about character reading. That to me is the same level.
Well, the way I interpreted the drawing in terms of the hierarchy point of view, though, is like it's only drawn in a hierarchy because we're trying to show the relationships between these classes and interfaces and functionality. But the reality is like if we were going to draw these in terms of the layers of the application, well, then we don't care about these interfaces. Those are details that we don't care about. What we care about is the policy, which is how do we do the encryption. Like encrypting is a policy. That's something we care about. And that's at the highest level.
And I think that character reader and character writer are strongly coupled to that. Like you can't have encrypt without those guys. It's built in. It's a dependency. So those to me would be in the same component. And because they're in the same component and totally bound to each other, I would say they're at the same level.
The interfaces.
Yeah, I think they could be. Yeah. I mean, I don't think there'd be anything wrong with splitting them out necessarily, even though it might just create additional complexity for no real gain. But I would agree. All right, so let's move on to the next pieces of this because some of these do get deep, and I think a lot of it gets a little bit clearer as we go on. But the key here was, and the takeaway is, the importance of this entire point is that the higher level components are now reusable because they've got interfaces to them. They're not dependent on any concrete. There's no dependencies that are pointing downwards. And so these things are literally completely decoupled from everything else. So they can be plugged in anywhere.
Yeah, you're basically able to, because of those interfaces, you can kind of quote, inject what you want to use in order for it to work with that higher level policy.
Yep. And it says that the policies that change for the same reason or the same time are bounded by the SRP, the single responsibility principle, or the common closure principle. So those words come up again. And this is something that's interesting, and I honestly believe it's true. I was trying to think through it at the time, but they say that the higher level components, the ones that are sitting up there that are abstracted very well, they typically change less frequently than the lower level components. And if you think about it, like you said, some sort of calculator, chances of it changing how it works is probably pretty low. And so it's a safe thing to abstract out.
Yeah, I mean, let's think about if you are writing banking software. The calculation for interest hasn't really changed much in how many decades now? Like that is a core policy within the business that hasn't really changed a lot. But everything around it, the frameworks that are used, the tools, the languages, the operating systems, the databases, like that, all of that stuff around it has changed a lot over the years.
Yep. All right. And now we get into the part that I think, go ahead.
Oh, I was just going to one thing to wrap up there is that those low level components though, that we were talking about should be plugins to the higher level. I don't know that we said that.
No, we didn't. And that's cool too, because they had the whole notion of a console reader and writer for the encryption thing, right? You could easily plug in a web page that had a couple of input forms, or you could say, pull this from a database. You don't care where it's coming from as long as it meets those contracts of this is an input and this is an output.
Yeah. I mean, it could be spoken voice. You could dictate it over the phone. And that's the point, is that that's what he means when he says that it should be a plug into that higher level, because there's that interface between the encryption policy and how it's reading and writing the data. Then when I said that you can quote inject whatever functionality you want in there, then that's how that can be a plug-in into it, right? So you could have it like, hey, you want your password encrypted? Call 1-800. We'll encrypt it for you, and it'll read back out what you should write down in your little password journal.
Hopefully you don't use that service too often.
I'm going to start that service. That's going to be money.
That's terrible. So this is the part, this is where I really liked where it started going into this, because how many times you said the word business rules when you were talking about something you're working on? hundreds, right? And I like how he breaks it down here. So I'll start it off with this one. Business rules are the rules or procedures that make or save the business money. That's pretty cut and dry.
Yeah, that's a great definition.
It is. And
Well, with an important distinction there,
yes.
or like, an asterisk there, they make or save the business money regardless of whether or not they were implemented by a computer.
Yep. If they did the thing by hand, if they were running interest calculations on paper at the bank, it's going to be the same as if they had done it on a computer, right?
Doesn't matter if you sold that car online or if a person walked up to you, introduced you to the car, and then had you sign on a dotted line. It's selling the car.
Yep.
Is the rule.
The what has to happen for selling that car are your business rules. And so here's where it's interesting. So they talk about critical business rules. Again, this is with or without a computer. These are the ones, when they call them critical business rules, they're critical to the business, right? Like a bank, interest, it matters. Loan origination fees, that kind of stuff. It matters to the bank. That is part of their core business.
So critical business data is data that would exist even if there weren't automated systems. You ever work somewhere with paper?
Not
I
in a while.
used to. It's been a while.
Yeah, not in a while.
Yeah, I was trying to think of like a really good example of that. And like when you mentioned paper, I remember like way back when, people filing their taxes by paper.
Oh man. Yeah.
Like
filling out the 1040 easy.
That data had to exist. It didn't matter if you had a computer to enter it.
Man, it reminds me. So one of my good friends, VP over at UPS, just retired after 42 years. It was a long time. One of the guys that got up there and was talking about, way back in the day when they worked together, the way he kind of got started was they worked in this area at UPS and everything was literally hand ledgers, right? Like they'd go in there and they'd fill things in. And if there was a mistake, they'd go back and erase it and they'd fill it in. And one of the things that this guy did was he was like, man, we can automate this stuff, right? So he took those business rules that they were literally handwriting for everything, inventory, accounting, all that stuff, and moved it into a computer. The business rule didn't change. Just the efficiency and the speed at which it happened was what was different. And this is where it ties the two together, right? Critical business rules and data are tightly bound, makes sense, and they're a good space for an object that we've heard about in domain-driven design, although it means something slightly different here, called an
entity.
Yeah.
Sound familiar? Like Triple D?
Here's the thing, and I want to preface this a little bit. Domain-driven design has very opinionated wording about how they reference some of these things, and the meanings are a little bit different here. This is more about how you separate your components in your system so that you have a clean architecture that can be maintained over time, right? DDD was more about solving a business domain problem. So just know that entity here does not reflect entity in domain-driven design.
And it's not a reference to entity framework.
At that either.
Maybe the word entity has become the new helper or manager or library or source or code.
Awesome. It needs to be renamed immediately.
It's used too much.
It is. So this is where they say an object that contains critical business rules and critical business data is an entity. That's a simple definition.
And they should be separated from every other concern in the application.
Yeah, sorry, I was just looking in the book.
That's fine.
If this is like kind of off topic, part of the course, if you had to read one book or you had to choose for somebody whether they read Clean Architecture or Domain-Driven Design.
I thought we were going to pick whatever book we wanted.
I think.
I guess it's kind of a rude question. I'm kind of pitting two great things against each other, and like as it's apples to oranges. But I'm thinking like, which one has more effect on my day-to-day coding?
I'm going to say JavaScript, the good parts.
Yeah, everyone's doing JavaScript now.
I honestly, no slight on domain-driven design. I loved a lot of what I learned there and the concepts. I thought they translate well, but I think in the grand scheme of things, the content in this book is more about making you think about how to build your software in a better way.
Well, so was DDD.
It was, but
I mean, obviously, the
More
audience that
maintainable.
you're talking to, that you're trying to make this recommendation to, is someone who's trying to be an architect or do architecture.
see, I guess that's where I don't necessarily see that. I think
These are both heavy architecture books. This isn't like, it's not like we're bringing clean code into the choice, for example.
so. I guess here's my take on it. Domain-driven design almost centered exclusively around the ubiquitous language, being able to speak to a business person and translate that into objects in an application that you could look at. Like, it was really about the communication and being able to say, this is what you need. I'm going to implement it in code.
Okay. Well, I would say that a different way, though. I mean, it was about keeping that language consistent in your code with what the business is actually using.
Yeah. So when you look at the code, a business person, you could literally talk to the business person about what that
And the
code's
business person could read the code and have an idea.
right. And that's important. I think that's valuable. What I like about this, and I don't necessarily see this as only an architect, I think the value that you get out of this is as a developer, like some of the concepts here with the inversion of control and data going one way, but the dependencies going the other. As a developer, you can think about these things and you can say, oh, I see how I can make this to where it will be easier to swap out pieces in the future or something like that, right? So
I don't know, man. I think if you're talking, depending on who you're talking to, though, if it's like a junior developer, would you tell them this, or would you say, hey, go read The Art of Unit Testing? Or, you know what I'm saying? Like,
well, when you open up the whole world of books, that's a different story.
right.
But
That's what I'm saying. Like the question was phrased to two books that are both heavy architecture books. So you're speaking to an architect. So you're already speaking to somebody who is not entry level.
Yeah, I mean, that's fair, but I think it's nice to plant those seeds. You know what I'm saying? Like, it's such a hard thing because we've talked about it so many times, and I don't want to go too far off topic here because I know we could talk about this forever.
That's Joe's fault. So
but I mean, we've talked about this, right? Like, we've just by practice, by what we've done in our entire careers, like your database is your core, right? Like we've mentioned that, and so you have a tendency to think of, okay, here's my UI, here's my service layer, here's my business layer, here's my database, right? And everything's pointing down towards that. This flips all that. And I think it makes you think about, okay, what's important? Well, storage is an infrastructure thing. Mm-hmm. It's not got anything to do with your business. It's literally just where the stuff exists. And so I think,
okay,
I like these for the book just to put those ideas in your head.
So here's my answer to this. I think that both would be extremely valuable reads to someone who is wanting to be an architect or trying to be an architect or is currently assigned an architect, you know, like any in that kind of role, right? I think that the Clean Architecture book puts it into plainer speak.
Totally.
The Domain-Driven Design is a great book, but it's more wordy and it's easier to get derailed and lose the understanding of what's trying to be gained. Like it might take you a couple times to grasp something. Whereas if you read this and then read that, you might have a stronger grasp of it. Because I feel like, and I don't know if you guys felt this, but I feel like I've gotten a stronger grasp of DDD having read this one.
Yeah, definitely.
So, which kind of makes for the case of like, oh, maybe I should recommend DDD first. But I kind of wonder like, oh, and if we flipped it, I wonder if maybe we would have had a much stronger understanding, or or at least I would have had a better understanding of domain-driven design having come from this one first.
You know, the one plus I'll give DDD over this one is he had a lot more code samples in it.
Yeah.
And so it was easier. Like if he said, like you said, he was very verbose in his descriptions of things. And so sometimes you get lost in it, but you could always look at the code and say, okay, I think I get what he's saying here.
And I'm not trying to say that as a bad thing. Like you've read Neil Stephenson, for example, I mean, that man could go on like 5 pages just talking about how you're driving down a gravel road, right? And he's describing every little detail about every little piece of gravel as you roll over it, right? Like, I mean, it's a Neil Stephenson book, so you kind of know what you're getting into, and you're like, okay, I mean, and it's good. It's great. It's a great level of detail, but you can get kind of lost in it at times. So, this one I would say would be the starting point.
Yeah, I agree. I think it sets up a lot of the foundation. And again, I think it's a good read for anybody just to plant those seeds so that you're thinking about this stuff as you're creating it. Whether or not you aspire to be an architect or whatever, I do think it helps you at least put things into perspective and hey, how do I build decoupled software so that it's easier to maintain over time? And thanks for derailing us for 10 minutes with that one simple question.
So just to backtrack for a moment then, going back to this entity, the last thing I had said was that the entities should be separated from every other concern in the application. So what I mean by that is, let's go back to this encrypting example that was given, right? That entity, right? It's the core business rule of how to do the encryption, right? So that layer or level, it's not concerned. It's separated from any other concern about how to read the data in. It's separated from how to write the data back out. It doesn't care about any of that. It's just going to use some simple interfaces to do that, and it's up to you to implement those interfaces to get the data in and out. It's not. It is isolated and separated from those concerns.
Yep. No dependencies on databases, third-party dependencies, user interfaces, nothing.
Right.
It's self-contained completely.
It's pure business logic.
Yep.
Yep. So next section is talking about use cases. And the difference here between use cases and like business rules or policies are that use cases are kind of additional business rules that are not critical, but they define how the system should work, but without having. They would have no impact on manual business operation. Like, this is something that you would do. It's like almost like an example of a behavior that your system needs to account for. It's a description of how the automated system is to be used.
Yeah, it's specific to software. Has no impact on the daily running of the business any other way. It's literally just how your software works.
And they indicate how and when a critical business entity should be invoked. They indicate the inputs and outputs, where they come from. Oh, sorry, but not where they come from.
Like,
very important.
Just to kind of back up on that for a moment there. We mentioned banking, right? And you might give a loan out to somebody. And if you part of the core business rule would be, how do you decide who to give a loan to? And the actual process of making that person a customer and filling out the loan paperwork, right? The steps that you go about doing those core business rules, right? Those are the use cases, right? So, if the customer's credit score is greater than this, then we will make them a customer and we will fill out this application and paperwork and whatnot, right? That's the example of a use case.
And that could be and that would be your automated system, right? So those are decisions made in your software. Whereas if some dude walked in the bank and you've known his mom for, 50 years, you'd be like, he's a customer, right? That use case in that software has no impact on how they do business inside that office. And that's what we're getting at. They're completely disconnected. The critical business rules are the same regardless. The use cases are for the software only.
Yeah, and the how the data gets in and out is totally irrelevant, and the entities have no knowledge of how use cases use them. And this is similar to the point we made before, where the object that contains the critical business rules and business data they're totally separated from every other concern in the application. These entities have no knowledge of how use cases use them.
Which, at first I didn't like this encryption example that he gave. But the more we go through this, the more I'm like, oh, this is so perfect. Because let's bring back up this banking example, right? If security is going to be important to you, right? But that encryption policy, that encryption entity doesn't care about how the data, where the data is coming from, how the data is being used, or what it's being used for, right? It just knows it's one thing. I'm supposed to encrypt some data, and that's it.
I got some data in. I'm going to spit it out encrypted.
Yeah, that's all it cares about. So it exactly as Joe said, it has no knowledge of how the use cases are going to use them. It doesn't care if it's for encrypting personally identifiable information. for a customer or for an account number or anything like that. It doesn't care.
And this is where we talked about the dependency inversion principle earlier. Where
Bingo.
Bingo?
I got bingo.
Yes, you did.
Yeah, that was the third acronym tonight. I won.
Oh.
Sorry.
Higher level components know nothing of the lower level components. The direction is inverted. Should I try and explain that?
Yeah, sure.
I mean, yeah, we touched on it already. So high level components know nothing of the lower level components. In our encryption example, the encryption algorithm itself didn't know anything about how the inputs and outputs might interact with, like, say, a terminal, right?
And the way that works is through an interface, right? That when you talk about dependency inversion, so the way that we've talked about it is you new up a new class, right? And you call that class and then some method in that class, and then it calls a database or whatever. That's like dependencies pointing one way, and actually the flow of everything still going that way. If you want dependency inversion, typically what you do is, instead of newing up another class, like you call some class and then it calls another class and whatever, there's an interface that goes between those two. And logging, for whatever reason, to me is an easy one to talk about, only because typically in any kind of software that you're going to put out in the wild, you kind of want to know when things go wrong. And usually the only way to retrace it is to look at a log file, right? Software does it all the time. Well, if you have your application and then you're using a library and you need to be able to log things in your application, you need to be able to log things in the library, you could just include that same logging application or that logging DLL or jar or whatever in both of those. So log4net or log4j, right? But that kind of sucks. Now you have a dependency in that library that has nothing to do with logging. You have a dependency on this log4j framework, right? And if some new framework comes out, then you're going to have to do something with your dependencies. Well, instead, if that third-party library just has an interface for an iLogger, you can new up that iLogger in your primary application and just pass it to that third-party library as the dependency. You basically told it, hey, I know that you're looking for this interface for iLogger. Here's something that fulfills that interface. Use it.
You know, we keep saying interface though, but it's important to note that, like, that's just one way that you could solve the inversion, the dependency inversion. You care to take a guess at how you might be another way you might be able to do it?
Not an interface. You could probably do like a service locator pattern.
It's not the one I was thinking of, but okay. Joe?
Yeah, I'm just thinking interfaces. It's where you depend on, I guess you could do maybe an abstract class or
a class, an abstract class.
Yep, you could totally do that. A subclass of it.
Yeah, you could subclass it, and then you could even take it a step further, because then you could go with a template method pattern inside of the abstract class, and so then your subclass only needs to implement, whatever pieces of functionality it cares to. Yep. The interface, I would say, is probably the cleaner, more common way, especially with like modern languages. But it's not the only way.
Yeah, that's true. But I guess that's the whole deal, though, is instead of letting that third-party library control how it's going to use that logger or what kind of logger it uses, you tell it what it's going to use. You give it to it. And that's how you invert the dependency. Instead of that thing knowing what to new up, you give it what it's going to use, and it just uses it. It doesn't care what it is, right? So I read some sort of example online that was interesting. Somebody needed something that worked in IIS, like a plug-in to IIS that was going to log messages on notifications, right? And when they first started out, it was a very simple thing. Hey, just log it to this particular area. But then as things came in, they said, oh, well, for certain types of things, we want it to email. Well, the problem is now when you go that route, what are you going to do? Have a bunch of if statements up in the thing that's really supposed to be this simple notification thing, having to know about, okay, well, how do I start up emails? How do I start up an SMS if they want to do that? How do I start up these? Instead of that, you just pass in the object that knows how to do this notification. You give it to it, and then it just calls it, right?
Well, think about this. I mean, this goes perfectly in line with this encrypting example. in that scenario, the input and output are the policy doesn't care. The policy is like how, writing the data right in some particular format, but where it writes it to, what could be a file or it could be an email. That part it doesn't care about.
Right. It just knows that when you call write, whatever you gave it, it's going to try and write it. And if you gave it a file writer, it's going to write it to a file. If you give it a database writer, it's going to write it to the database.
Yeah.
Right.
Well, because again, and I'm trying to make the distinction here because its policy is the format in which it's going to write the message.
Right.
Right?
It's going to call
you're going to
write.
give it you're going to give it a message. You're going to give it some string like, ran into this error, but it's also going to include other things like here's the time, the date, the thread, what level is the message like. So it's going to format that message. That's what its purpose is to this going back to formatting being a policy, right?
Yep.
So just to pick back up where we were here with use cases, these use cases are specific to a single application, but the entities are generalizations. So our entities could be used across multiple applications. They're not tied to anything. They don't care.
And I really like the point that that use cases are specific to a single application. If you think like about a batch processor or a mobile app or a website or some sort of service that's running, like those are all different applications, but they all use the same entities, ideally. So I thought that was kind of cool. And one thing the book doesn't really touch on is when I think of use cases, I think of very much like UX, like this is what the user does. And I think there's a lot of carryover. It's just that this is kind of a more specific like software architecture-y definition of use case.
Yeah, I mean, it's kind of interesting that you brought up the user interface because there was one part in here where he says that the use cases do not describe how the system appears to the user. And I wrote a comment to myself because I was like, well, that depends on who you're asking, right?
Yeah.
Like you ask a UI designer and they're gonna be like, whoa. Of course it describes how it's supposed to appear. Like when that user clicks the next button, the use case is this is what you're supposed to see, right? So I think that part depends somewhat on the audience.
Yeah, I agree. I think he was talking more from a server side type, or I guess it doesn't even have to be server side, like a desktop application or something. The business behind it.
And there used to be some like I forget now, but there used to be some way of kind of like writing sentences as use cases where it's like I, as a normal user, want to be able to whatever, so I can whatever. And so there's like this kind of structure.
We've talked about this. This is the given when then.
Yes, that was it.
So given I am a logged in user, when I add a product to my cart, then the cart is updated to reflect the quantity entered.
Man, just give me a storyboard.
Oh no, man! I love given when then syntax for use cases. It's so awesome.
It's good for writing unit tests. I will say that because then it's very spelled out, right, in very businessy terms. But no,
I mean, it just makes it so obvious to like what your codes should be. If it's well written, given when then, it's really good.
But who wants to write like that?
Yeah, I do. I have.
Oh, you want to like write a ticket and like give 10 of those in there?
I definitely have.
Yeah. You have.
I definitely have.
Yes.
Well, I don't want to write any tickets.
Well,
I'm a ticket crusher, not a ticket writer.
Oh, that's amazing. All right. So this next part was pretty interesting to me. And I don't think I ever thought about it this deeply. The request and response models. So use cases accept simple request objects for input and return simple response objects for outputs. Now, I've always done this at like a service tier, right? Like you have a search request and then you have a response object. Like that sort of makes sense to me. But what they advocate for here is doing it in between boundaries at different levels, right? Mm-hmm. So they're saying that your request object that went into your service call should not be the same request object that goes into your business layer call. And that should not be the same request object that goes into your database layer call. He basically makes a very strong point of those should be separate at every level. And the reason, and this makes perfect sense, is they don't always change at the same time for the same reason. And it kind of sucks when you think about it because you're like, man, am I really going to have to write, request response objects for every single tier I have? If I have a 4-tier app, I've got to have 4 pairs of these things all the way down? Yes.
But this is going back into the conversation that I had about like, where do you put your interfaces? This is part of, where do you put the DTOs, right? Because these request and response models, like, where do you put these things? If you're going to make a request to some higher level entity, right, it has to know how to read that data, right? So the interface for that thing, or if you're just going to put the DTO there, it needs to be at the same level as that entity, right? And similarly, if it's going to respond with an object back, right, that definition of that object is going to have to be at the same level as that entity so that it can new it up and return it.
Which means you might have a bunch of translation in between all those layers, right? That's the thing that stinks. So yeah, you're right. Whatever the inputs and outputs are at any given layer, you probably want those there because it makes the most sense there. It's separating it out seems like an unnecessary abstraction. But that also makes you say that, hey, when you have this service layer that got called, and then that needs to talk to the business layer, you're going to have a translation of whatever that request was to go into the request into the next layer. And then you have to translate that to go into the request at the next layer, right?
That's fine. I mean, that's the adapter pattern then.
It is. And here's the thing, and I think it's worth calling out, is they could be the identical objects all the way down, right? Like, it could be that you have, let's call it bank calculator request up here, right? That's going to be your request object. There could be a bank request object at the next layer, and it could be basically a copy and paste of that same class. But the key is it is separate, right? So if that thing ever has to change, you don't have to funnel that change all the way up. It's literally just, you're going to have to change how this layer pushes data into that next layer, right? So essentially what I'm saying is the multiple layers aren't referencing the same class.
Right.
Almost identical looking classes.
Mm-hmm.
Right?
It hurts, man. It hurts.
It does. It does. But he makes a strong case for it, right?
And we had a very similar conversation with the DDD conversation when we talked about, like, if you had a customer object that was in a customer service namespace versus the customer object that was in the shopping namespace or something similar to that, right? Like, don't get hung up on this idea that duplication is necessarily bad, that you can't have these things repeated for specific purposes. Because what you're really trying to break here is, these things are going to change at different times, different rates for different reasons. So you're trying to break that dependency so that when it does change in one, it doesn't impact the other.
Yeah,
so
it doesn't
having
flow
this
all the way
adapter
down. Yes.
pattern where it's going to adapt the data from one DTO to the next isn't necessarily bad, because it insulates you from change impacting something higher level.
That's the key. It insulates you, is exactly what you said. It breaks the chain.
It's
right
the
there.
firewall.
Yes.
Going back to the previous episode.
Now, you don't have to like it.
No, you don't. And it feels wrong, right? Like, code duplication feels wrong, but there's a very good reason for it here. And hopefully what we all just said there drives that home.
Well, it's like he said in the last episode, we covered it. Like, there was some comment where he says, like, we see duplication and we feel honor bound to remove it, right? But there's different kinds of duplication, right? There was like what was it, like accidental duplication and then true duplication or something like that. Like, I forget, but one was where the things might look the same, but in reality, they're going to change at different rates for different reasons. So it's just coincidental that they're the same.
Even if it is basically a copy and paste. I mean, in this case, it could be, right? It could be. But it was interesting. The next thing that they say is there should be no dependencies on anything. These should be simple objects. The request and response objects should be POCOs or POJOs or whatever you want to call them.
DTOs.
They're plain old objects.
Now, let me tell you, I don't envy the programmer who has to defend this in the pull request review. Listen, Coding Blocks told me that sometimes there's coincidental duplication. And that's why I've copied and pasted this class 4 different times.
You tell them to send their complaints to the Slack channel.
That's right.
That's right.
And I love this too. they say that it seems like it might be a good idea to return that entity object with your data, right? Like, hey, we've got this encryption class up here. Let's just tack it on to the response object here because then everything can use it. No.
Here we go. Okay. So Entity Framework has been our let's say the
child.
Yes. the whipping boy du jour,
yes.
Right? We've beat up on Entity Framework for many episodes now about this because it's very tempting to just return back that Entity Framework object, right? But this is making a strong case for why you shouldn't do that. And same with the domain-driven design book was making a strong case for why you wouldn't want that exposed outside of its layer, right? And he even made a point, I don't think it was within this particular part of the book, but later on, where he's saying like, you might be tempted to have an object that is a row of a database and you're tempted to remove it. Yep. Or to return that row, but you can't do that because then you're leaking that dependency, and you don't want to do that.
You're leaking where it came from, and that's the problem.
And now you're coupling everything else to that decision that you've made, which was, hey, I want to not only use Entity Framework, but I'm going to use SQL Server.
Yep.
And now when you decide to change either or both of those, you've made more work for yourself.
Yep.
And I've seen it, especially when it comes time to actually change stuff in the database. You're like, oh, I don't know. There's all this downstream effects. Like, I'm going to change this one thing. It's going to break a whole bunch of stuff. And that's an example where you're missing that installation there. Let me tell you, though, if this is the worst thing that you're sending me in your pull request, we're going to be all right.
Right on. Yeah, man.
Well, yeah. And, I know we're picking on Entity Framework here, but not because we don't like it.
No, yeah, nothing at all.
Nothing could be further from the truth. But it's just that that meme about like I've seen things. Right? Yes. Like that's what it feels like. And so that's why we pick on Entity Framework, because we've seen some bad things with Entity Framework where it's like, this is dirty.
And it's just probably the easiest to pick on because it is probably the most ubiquitous in terms of ORMs.
In .NET land.
In the .NET world, yeah, definitely.
Yeah.
But,
now, here's the other thing, right? Like what you said about they change at different times, the whole reason why you would never include this thing back. What if that, for some crazy reason, that encryption component did change? Now you got to change all your downstream code to handle that change, right?
Not necessarily. No.
That's why they say don't return it though. So if you're returning a response object, you don't tack on that higher level component, because if you're returning that thing down and it's now 5 layers deep and something 5 layers deep is trying to use it and that thing changed, you've leaked out that dependency all the way down, right?
It'd be the other direction though, right? It would be like not passing in your database row to the encryption.
Oh, no. But remember, the whole point was do not return a reference to the entity object. So what I'm saying is, if you got a response, you went to use that entity object, and instead of just getting the output of it and sticking it on a property on your POCO.
Oh, I see what you're saying.
Yeah.
Okay.
You don't return it back out because now you've made other things dependent on that entity object when really it should have just been your use case.
So you would return back, here's the encrypted string.
Correct.
Not necessarily which encryption algorithm you used, which that algorithm might be encompassed in, enclosed in a particular object.
Yep. Hey, and this is where I did put in the note, common closure and single responsibility principles. Boom, I remembered it. Yeah. All right.
Step to a Slim Jim.
Yeah.
I thought we already agreed that was wrong. It was the closed caption programming.
All right. So who wants to conclude on this one? It's just going to.
So just to wrap up this section, then the business rules are the reason a software system exists. And these business rules should remain pristine, and they should remain independent and reusable.
All right. Who's the next one? You got to do it properly. Whoever does it.
Outlaw's the only one who can do it.
Well, man, now this is. I was just going to say it.
No pressure. No, you can't.
You're the chosen one.
Yeah, that's right.
All right, here goes. Are you ready? Screaming architecture.
That's pretty good. I like it.
That was really good.
I like it.
So an example here is we talked this a little bit before about how your project or your application kind of should reflect its purpose. You can imagine if in the example of that encryption program that we were talking about, if you opened it up and you were immediately confronted with things like character reader, line scanner, pretty print, formatting, like those things to me scream console application, but they don't scream what the purpose is, which is that should be encryption. So in an ideal world, I should be able to open this project and like be confronted immediately with the purpose of the application or the component, which is encryption. And the whole thing should be roughly themed around encryption because that is its reason to be.
Man, I love this. Last night, I started up Visual Studio on the Mac, and I created a new application. And you open it up, and what do you see? Folders, views, models, controllers. And I'm like, man, that burns me up. And even the same thing, like when I was initially looking into doing React.js on the web, all the tutorials were controllers, views, models. I'm like, no, right. I'm not burying all my stuff in there. If I'm writing an application about podcast, I'm going to have a podcast folder, and I'll put my views, models, and controllers in that. And if
I'll put my views where I want them. Thank you.
That's right. Like, dude, this stuff makes me so mad. And honestly, I don't know about you guys, but anytime I start to learn something new, it really frustrates me. When I look at the file structure, and the file structure is something like source views.
Right.
And I'm like, no, in my soul, I can't do this. I've never been able to do that, by the way, because I look at it and I'm like, so you're telling me if I write a real application that's got some real meat to it, that I'm going to have 50 views in one folder? Really? No. And then, by the way, all the models that are used in those views are going to be in some models folder. And I'm going to have to scroll up and down to find all this stuff, and it's not going to make any sense. Man, I actually got angry and happy when I read this because it reminded me of all the bad. And I literally just created a project in Visual Studio last night, and it did this very thing where it's like it screams framework,
right,
and tells you nothing about what you're actually doing.
Definitely, creating a solution with Visual Studio was definitely the thing that came to mind. Like as I was reading this, and I was kind of like, okay, well, what am I thinking of? Like as an example of how this is wrong. When you create an MVC app, web app with Visual Studio, and it's like, here's your models, here's your views, here's your controllers, right? Like that was definitely the example in my head of like, oh yeah, that's just the architecture of what I created and the tooling that I used. That's not necessarily anything about the application I want to create.
But I don't want to just pick on them. Like it seems like every tutorial out there are the same way. Like, okay, so we all do EXTJS programming. Go read their tutorials. Views, models, stores.
Right.
No, that's not how you write software. And if you do write software, you're doing it wrong if you're doing it that way. Straight up.
We're all doing it wrong.
Yeah, we're all doing it wrong. But I mean, seriously, like it is very important that somebody be able to open up your application and look at it and say, oh, okay, there's a customer service section. Okay, there's an accounting section, right? Like, make it obvious. It should scream the architecture.
Well, what if we said that maybe, because I definitely think that websites are the biggest defender here. And there's been times I've downloaded like application skeleton projects and stuff from GitHub just because it automatically set the folders in the prescribed way for me. And I heavily dislike that. But if we're saying, you know what, this is my website project, it's going to be little and tiny, and all it is basically a facade for the website. And I'm going to have my other stuff in some other component. And at that point, then I think it's kind of fair because I'm saying, well, my project is the framework. It is the website. Yeah, I still don't like it. I just don't have a good solution because I get that if I have like an ASP site or something or a Angular site, like I like that things are kind of organized by layer, and I think it makes sense. And it's okay to hop around, although you inevitably end up with like 5 different freaking things open that span all the folders anyway. So.
And that's what I was going to say. Yeah, go ahead.
The problem is this, though. I mean, we talked with Michael and Clint about a while back about the new project. The file new within Visual Studio, right? And that whole experience and trying to improve upon that, right? So if you're a developer who is working on the tooling to improve the file new experience, right? You can't know what the end application is going to be. Like you have it by a name, but that tells you nothing about what it's, what it really is necessarily. So, I mean, I guess it's a double-edged sword, like, from their point of view, right? Whether you are authoring Create React App or you're doing file new experience in Visual Studio, like you're going to lay down some structure that as a guide to somebody, but it's going to be up to that developer to just take that as like, okay, this is an example pattern of like how you think things should be laid out, but it's not necessarily the end all be all answer, right?
Yeah, I think that's fair. I mean, he even goes in this chapter and says, people who write frameworks are very proud of them, and they should be. I mean, there's a ton of work that goes into frameworks to enable you to write software faster, right? That's the purpose of a framework. And if it's not enabling that, then you probably chose the wrong framework. But on the flip side, he also says you should scrutinize those things. If your software starts looking like it's about the framework and not about the business problem or whatever you're actually trying to create, then you're probably not doing it right. And I agree with that. I actually like one of the bullets we got here. If your architecture is based on frameworks, then it cannot be based on your use case. I agree with that. If you're coding around it, go ahead.
I was just thinking, like, if I were to start up a new Vue what project here, I was looking at somebody's recommendations. They end up with 18 total files and folders just for like the basic kind of like, there's some files in there for like your index or you're setting your CSS or whatever, your basic stuff routing. And there's a couple folders for where you're supposed to put your stuff. Then there's an npm folder in there, and there's a node folder just full of packages too. It's just like crazy to think like, hey, I'm starting a new website and I've already got 18,000 files and folders. And then the first thing you do is you go into you hunt around for index, right? And then you like delete 6 lines and put your 2 lines in there, and you start from there. It's just crazy that you've got this whole huge exoskeleton kind of built around you.
Yeah, go run Create React App and then go look at the 100 of node modules that are in that folder.
Yeah, there's a video of me doing just that. I'm like, oh my gosh,
my computer ran out of space.
Why are there so many?
Pause the video.
Yeah.
Oh man. So here's another anecdotal thing that I think is kind of apropos here. A house's architecture is focused on usability, meaning does it have a bathroom? Does it have a kitchen? Does it have, a bedroom? Are there doors in between all those things? Are there windows? Not whether or not the outside's built with bricks or stucco, right? And so what they're saying is your application should focus on the usability of the application, what it's supposed to do. Worry about the frameworks and the infrastructure decisions when the time arises. Focus on your core.
And sticking with the theme of this chapter, though, that blueprint for that house screams what it is.
Yes.
Right?
Yes.
So you can immediately look at that. So if you were to look at your code's directory structure as a blueprint, for example, or the solution structure as it might look in like an Eclipse or Visual Studio or Visual Studio Code, whatever you're using, then if you think of that as the blueprint, does that structure alone scream the architecture and intent of your application?
Hopefully the answer is yes.
Yeah, and I was just thinking, like, if we were building a house and we were using some sort of framework, what we're saying kind of like is a bad example would be I open up the house project and I see folders like surfaces and portals and measurements, because that's not housey. Like, sure, houses have those things, but that's not specific. A better way of thinking about it would be if I open up that house project and I see a folder called doors or windows or walls or like those things. I see that I know what we're talking about, and it helps guide me as a new programmer and an existing one to the place where I want to go. Like, so yeah, I mean, I like this idea. It kind of bothers me. I think I have some like internal conflict because it's so common to see this kind of stuff in front of frameworks that I wonder, it's like, are they all doing it wrong, or Is there something I'm misunderstanding?
I didn't think about it, but I think what Mike said was probably exactly it, right? Like when you're building the tooling to set up your framework, like you said, you can't know the use case for what people are going to use. So you have to set it up in a way to where it makes sense, right? Creating a views, models, controllers thing, fine, right? You scaffolded up the application. Now to really use it, there really should be something that says, hey, don't leave these out here. Put them in a folder or something, right? Like,
I think Uncle Bob has gotten to the point in his career where he's got people that he can pay to do the UI for him.
So he doesn't care.
Yeah, I need to figure out how to get there.
Oh, that's awesome. And he points out again, he's always deferring decisions, infrastructure type decisions, the details until the last possible moment.
Yeah, I'm totally kidding, by the way. I know he's done a lot of UI stuff.
I'm going to tweet him that you were terribly serious.
Oh, I'm sorry. I'm just kidding.
I'll be right back.
And then they pose this question in the book. I'm pretty sure that we all would have come to the same thing, but what is the web? Is that, what layer is that?
It's your I/O. So it's low level.
Yep. Exactly.
All right. So there's the theme and the purpose of the architecture. So the architecture is all about structures that support the use cases of the application.
And architecture is not a framework, nor is it supplied by a framework. And that's kind of what we were talking about before with those web projects where
And so just, in going back to the purpose of this, though, similar to what Alan said a moment ago, a good architecture allows you to defer and delay these decisions, but it also makes them easy to change your mind about those decisions.
Yep.
Yeah, and I think talking about those frameworks the way we did like really exemplifies that. Like the first thing you do is you go in there, you like chip your way into where like something that actually matters, which is tough to find, and you like chip your little changes in and then refresh it. And that's the opposite of deferring decisions, the opposite of delaying all those details. It's like you're inserting your application into their framework.
A little funny story to go along with this with the details. So I was trying to force myself to use Visual Studio on Mac, just see how it was, if it was good, if it was bad, whatever. And, in Visual Studio on Windows, if you start up a new app, you can create a local database, right? It's like a little mini SQL Server or SQL Server Lite baked in.
Oh, local DB.
Yeah.
Yeah.
And so, I was going to go do that really bad because I was not deferring decisions on what I was going to do. I was just going to set up a database. In Visual Studio for Mac, they don't have that. And so it forced me to defer my decision. And I was like, oh, you know what? This is a good opportunity just to find an interface and mock some data out, right? So it kind of forced me. So it was almost nice that it put me in that mind like, no, thou shalt not have the local DB and you will do this right. So
in other words, the takeaway here is in order to like really take advantage of these principles and to write good code, all Windows developers should do their coding on a
Mac.
Unix type platform.
That's right.
And all Unix developers should do their development on a Windows type platform. And then that way you're forced to write good interfaces and mock classes.
That's right.
And delay those decisions for as long as possible.
There it is.
And you got to go to lunch together and hate.
So what? You go to lunch together and hate?
And hate.
Yeah.
All right. So we now know that frameworks are tools. And that came out wrong. They are tools that we use. They are not ways of life. They are not our architecture.
Yep. And as we said a minute ago, he says, look at them with skepticism. And I agree with this. I think that's legit. They should not dictate your application architecture. You should not force controllers, views, models, etc. And then he also says, if you're going to take a framework, think about the two things. How should you use it? And how should you not, or how should you protect yourself?
That point there was my favorite takeaway from this section. How should you protect yourself away from the framework that you're using?
Isn't that interesting?
And in JavaScript world, I think writing your own modules is the answer to that. That's it, right? That's how you keep yourself away from that. The more you chisel your stuff into those folders, the worse off you're going to be. So if you can kind of package those guys, like otherwise you're totally at the mercy. just not doing it. And we're not saying don't ever use Angular or React or Vue or Ember because those guys are totally prescribed frameworks. We're saying do it, but don't let them dictate your application architecture.
Right.
So, yeah, I was going to bring up React as an example then, because like if React is a framework.
Well, it's not. Angular is. React is not. React's just a view layer, right?
A Vue framework. Yeah. You wouldn't call it that?
No, not so much. I mean, they don't really enforce much. I mean, if you just want to create a React component with a few lines of code and jam out some HTML, you can totally do that. Like, there's nothing stopping you. It's not necessarily going to be the best way to do it. Angular is a framework. Angular is full on MVC, right? I'd say Vue and React are very much just view layers that you can basically do as little or as much of it as you want. There's no prescribed major path for any of them.
I mean, yeah, I was just curious to see like what it refers to itself as, and it's referred to as it's just a library is what they refer to it. But and looking at the Wikipedia page, they say it could be used in combination with other libraries or frameworks.
Yes. So typically, what you hear about with React is it'll be used along with something like
Redux.
Yeah, Redux or Flux or any of those types. Those are frameworks, right? Those dictate how you do things and how data flows. But React itself is literally just spit out some HTML on the page, which is, kind of nice. So,
quickly wanted to go over testable architectures. If you've done your job right, which a lot of times means unit testing up front, then unit testing should be easy to do. Because as we've talked about many times before, if you put your unit testing off, it can be really hard to do because it's really hard to set up your code in such a way that it's going to be unit testable. And a lot of the reasons that your code is hard to unit test is because it's mixing these levels. It's doing things that it kind of shouldn't. And unit testing is a nice way of kind of enforcing that. And entity objects will be plain old objects with no external dependencies. So those should all be nice and testable. Use case objects will coordinate the use of entity objects. Again, no infrastructure dependency there. So yeah, testability is great.
Just to step back, where I wanted to finish my point with the React thing though, because okay, fine. So let's say React isn't a framework, and let's pick on Angular for a moment. How do you protect yourself from Angular?
You don't.
I mean,
no, you don't. You buy in or you don't.
You do as little as you can in Angular, and you do as much as you can out of it.
I think what Joe's saying.
Yeah,
which would be totally weird. You've never seen an Angular app written like that. But you would write all of your JavaScript, all your core JavaScript functionality would be outside of Angular as much as possible. And you would only use that, I guess, for the presentation.
Man, that seems like you're fighting the framework at that point, right?
I know.
Yeah, it's such a tough.
But that's
thing.
why that statement that he said, how do you protect yourself from the framework? That's why it kind of hit home for me.
That's when you use something else, right? Like you almost just go after other patterns. Like I said, Redux is a good one, right? Like it's more of a prescribed pattern than a framework. Whereas Angular is a full-on MVC framework. Like you have to code within the construct of it. Otherwise, it's just not going to work right. So, yeah, I think when you choose something like that, that's what it is. But I think you can still architect it in a way to where it would be meaningful. Like you could set up your folders to say, hey, this is my customer service area. This is my accounting area, that kind of stuff. So that's a hard one, man.
Yeah.
I don't know.
All right. Well, let's just wrap this up by saying that your architecture should quickly identify the purpose of your system.
Yep, should be screaming that architecture.
Oh man, I love this. I put this in here. So he wrapped up this particular section with, what happens? You've written the software, and then somebody comes over to you and says, "Hey, we see some things that look like models. Where are the views and the controllers?" And then your response should be, "Oh, those details, they needn't concern us at the moment. We'll decide about those later."
Right.
Like, how awesome would that be? I've never been in a position to say that, but that would be pretty cool.
Yeah.
All right. So
It's kind of like Obi-Wan talking.
those,
These are not the views and colors you're
those
looking
don't
for.
concern you. Oh man. All right. So with that, hey guys, for those that did leave us a review or have in the past, like we've got many now, and we read them all. Thank you very much for taking the time to do that. As always, if you wouldn't mind doing it, please go to www.codingblocks.net/review and leave us a review on iTunes or Stitcher, or I think even Podchaser we have. So any one of those things, you can find the links up there. So if you want to give back, that's a great way to do it.
All right. And so with that, let's go to my favorite portion of the show. Survey says. All right. Last episode, we asked, what is the oldest code that you actively, regularly work with? And your choices were less than 1 year, green as can be, 1 to 3 years, was there life before Angular? 3 to 10 years, back when JavaScript only ran in the browser. 10 to 15 years, pre-jQuery, we had to get element by ID back then. Or more than 15 years old, pre-Stack Overflow. You either knew it or you didn't.
So I think it's my turn.
Yeah,
I'm going to
your
say
turn.
most people say 3 to 10 years, and I'm going to go with 36%.
36. 3 to 10, 36. What do you say, Joe?
Just because Alan stole my answer, I'm going to say 10 to 15 with 28%.
Okay.
They're programming in COBOL now?
You couldn't.
10 years is not that long ago.
Yeah, it's really
long ago. See the gray in my beard? This is because of JavaScript.
See, I have a beard because all the hair fell off my head down my
Yeah, I mean, I'm wearing a hat for a reason, and the reason is JavaScript.
All right. All right. So then Alan wins.
Oh, really? I even fell within the percentage. Nice.
3 to 10 was by far the most popular. 43% of the vote.
Nice. Yeah.
Yep. It was by far and away the winner.
Okay.
We sadly, we do have some that are working on
More than.
apps that are 10 to 15 years and that are more than 15 years.
Ouch. What was
In
the
fact-
second most popular?
Those two.
Oh, man.
Wow.
Yeah.
Ouch. I'm sorry, guys.
Those two were tied for second.
I mean, maybe you like it. I don't know. It's,
Maybe.
It has different things float their boat. So
Well,
I would not want to.
huh.
Yeah, that was. Yeah. All right. So
That's kind of sad. I always felt like looking at job postings, it always seems like they're like the new projects, but maybe that's kind of like you tend to see more job postings for like newer, hotter projects because those are the teams that are hiring, and others have kind of solidified.
well, you guys are being like really negative about this. Maybe
I think it's
the
amazing.
people that responded with those answers, they're all working on something like, they're working in C and they're working on the Unreal game engine or they're working on the Linux kernel, but they're doing fun, cool things in a cool language, but it's just an older code base.
We'll go with that.
Yeah, I mean, I think 10 years is not crazy. Like, I've written lots of code more than 10 years ago. It was all awesome.
All right. So with
Show my age here.
with Valentine's Day coming upon us, this episode survey is, have you ever made a mixtape? And your choices are, does a playlist count? Oh, it doesn't? Then no, I haven't. Or, man, I got my technique down in everything. I know exactly when to play Bon Jovi's 5 Words. Yes, I have.
I can't wait to hear the results of this.
So I gotta wonder, like, do teens these days like send like a YouTube playlist?
Yeah, man. teens these days don't even talk to each other. They just sit there and they're standing next to each other, tapping on their phones, right? Like your friend's phone buzzes. Yeah, I just sent you a message, right? Like there's no such thing as interaction.
I know so little about it. I have no clue.
Yeah, you didn't have to woo anybody nowadays.
Did either of you get my 5 words reference though?
I did not.
Nope.
No?
Wanted,
I know who Bon Jovi is.
wanted, dead, or no.
Isn't that like a thing in the Bon Jovi songs where it's like, these 5 words I swear to you?
Yeah.
Oh,
He's
man.
always saying that.
No, I didn't get it.
All right.
Man, that's going back before my time.
What? Liar. For your time.
All right, so getting back in here, we're going to get into the last parts of this. So here we are on clean architecture. It's really about the separation of concerns. We talk about it a lot. We've mentioned it about 1 billion times in this book, and that's really what it is. Dividing software into layers.
Like an ogre.
Like an ogre?
Yeah.
Okay.
You don't remember like ogres are like onions. They got layers. From what's the movie name now? Shrek. There you go.
Oh man, I don't remember that.
Sorry, man. My ogres are all like World War Warcraft based now. Like I just think of like the 2-headed guys. Sorry, man. Anyway, this I wanted to mention. This is actually the chapter that that shares the name with the book, right? So we're finally talking about. We've been building up all this time to the clean architecture, and it really brings a lot of things together. We've talked about the separation of concerns. We've talked about the layers. We talk about being independent of frameworks. Things should be testable. It should be independent of a UI, database. They should be independent of interfaces to third parties. We've talked many times about how dependency injection is really crucial to being able to do this. And now we're kind of all folding it into one single picture.
I want to just wrap that, come back to that though, because he said that we're finally in, the book is titled The Clean Architecture. This chapter is The Clean Architecture. So we're finally learning how to do the clean architecture. This starts on page 201.
Welcome to the beginning.
Chapter 22. And we're finally getting to this is the clean architecture. Okay.
That's awesome.
Let's discuss this diagram that we are, I don't know if you've heard, but our ability to describe a diagram is amazing.
Yeah, man.
We're working on it.
I will say it kind of sucks that this diagram is completely inverse of the language that you would use from high to low level components.
Okay. Yeah. I thought about that.
That drives me a little bit bonkers.
Okay. First of all, let's get into the diagram. Yes. The diagram, as he titles it, is the clean architecture. The diagram, as the rest of the internet would describe it, is the onion architecture.
It looks almost identical, man.
I was a little bit bothered that he's been really good about citing references and whatnot and giving credit to other things, or calling something out if it's known, already a known thing. And it kind of I don't know, there was something just irked me about it. Why are we not facing, calling out the elephant in the room here? Why are we ignoring that?
It's pretty close. I mean,
I thought he did mention it in the book.
I didn't see it. I never saw it.
If he did, I didn't see it.
Yeah, it wasn't said.
So, okay, we've been dancing around this onion architecture diagram in all of our previous conversations and with the high level and the low level conversations. But I think I got a way to picture what you just described, where you were where you're saying it's the inverse of how you would think of it. Maybe it's this concentric circles within each other because we're looking at it top down. But if we were to look at it from its side, maybe it's a cone, an inverted cone.
It's like a ziggurat.
So
it's the peak of it is the entities.
Yeah, it's an ice cream cone sitting upside down on the table. So that the very tip of that cone is the entities, and as you go down closer to the table, that bottom layer that's touching the table, that is your external interfaces, because that's the interface that cone is making to the table.
I mean, that's a good description. It's not how I looked at it, but you make a good.
You're right.
Argument.
It's not how I looked at it either. But as you guys corrected me on the high level versus low level, right? That was kind of in my mind, like how I was able to like make sense of it all. I was like, okay, it's a cone.
Okay, yeah, I'll buy that. So let's hit it here. So the innermost or the tip of the ice cream cone, which would be facing up towards you.
Yeah, but we should say ice cream cone because you hold them upside down.
Yes.
Let's go ziggurat. I love
I don't know what
ziggurats.
that is.
What's a ziggurat?
Okay.
It's like the pyramid that has the steps, like a necropolis.
Okay. I'm gonna say, how about a street cone then? What would you call those? Like the orange cones
Okay, there you go. Yeah.
that you would see like in a construction site or like wherever they're trying to like direct traffic.
Okay, there we go. So
A road
a
cone.
caution cone. A cone. We don't even know what to call these cones.
Dang it.
It's a freaking ice cream cone that fell out of your hands. You lost your ice cream, and the cone's sitting on top of the table now.
Traffic cone. That's what they're called.
All right, a traffic cone. Here we go. So the innermost tip that is pointing up is your enterprise/critical business rules. That's what we talked about. Should depend on nothing. It is literally floating out there. It's pluggable. You can put it on anything you want. The next ring in, so moving further down towards the road, the ground, as it were, is your application business rules. This is your use cases. Then your next fatter ring as you're moving down towards the ground is the interface adapters, your gateways, controllers, and presenters. And then the one that is touching the ground, these are your outermost layer here. These are your frameworks and drivers, devices, web, UI, external interfaces, DB, file systems, all that stuff. So as he put it, you're going from more abstract down to the details. And the details, even though it sounds really weird to say it, is the database. The details are the UI. The details are those things that you could literally swap out if you wanted.
Yeah, and just look at to go over real quick again. So the entities, we said that's the core. That's the thing that's used by everything. The next layer there is the use cases. And I wanted to call that out specifically because the use cases, we said, are application specific. So that means everything past that point is application specific. Your gateways, your controllers, your presenters, application.
Mhm.
Your database, your external interfaces, your UIs, those are all application specific. The only thing that is not application specific is your entities.
That's business specific.
So again, looking at this thing top down, then, like the entities are our innermost circle. They are the most general, and they are the highest level within the application.
Yep. So basically what we're saying is the inner circles are your policies. Your outer circles are your mechanisms. In the Onion architecture, I purposely, in the show notes, I put infrastructure in places because I love that terminology from the Onion architecture, right? Databases, file systems, that's infrastructure decisions that you make. And I like that naming, like mechanisms. I like the notion that it's actually something you put in place. The inner circles, your entities, cannot depend on anything that is further. In the case of we're talking about looking down, it can't depend on anything further down from it. Everything at the bottom depends on everything at the top, right? That the dependencies go up, not down. And the outer circles cannot influence the inner circles. So the things down at the bottom, your infrastructure, your databases, all that stuff, it cannot dictate what your business entity is doing.
Yep. And then we're going to go over basically each one of those. They're not layers because it's not an onion. We're going to talk about each segment of the cone here. And entities are that core there that are shared between applications. They should be usable with many applications and should not be impacted. It's just what we said before. They encapsulate the most general high-level rules. So calculating interest, right? Well, what are some other rules that would live in here?
Encryption, calculating interest.
Order tax calculator.
Yeah.
Okay.
Amortization sheets. All kinds of stuff that just boils down to it, right?
All right. So next layer is use cases. Use cases are application specific, and the changes here should not impact the entities. And they shouldn't be impacted by details further down on the cone, like what database you're using. So if we remember those use cases, you want to give an example of one of those?
A use case that came to mind was like batch processing of orders, right? Like if you have something that needs to be released to pick out on the floor or something, that's a batch process that is very specific to your application, right? You're going to go through, you're going to print out paperwork and send it out to the floor, or create some sort of digital report that people are going to go use.
Well, the example we gave before was if the customer's credit score met a certain limit, then you would create a customer object for them, for that person.
Initiate a new loan. Yep,
yeah, to initiate the loan.
Yep.
And those details are abstracted. So how we get the credit score, like how the loan is provided, that stuff is at a lower level. This is just that use case. It's that description of what should happen.
Yeah, so these use cases, they orchestrate the flow of the data in and out of the entities, and they're directing the entities to use that critical business rules that we talked about earlier to achieve the objectives of the use case.
And then on to interface adapters. These are the things that convert data from the different data layers to the use case or entity layers. These are things like presenters, views, controllers. No code further in should have any knowledge of the database. I guess in our case, we would say no code further up. So the use case and entities have no knowledge of the database.
Right. And this is what we said right here. This converts data from data layers to use case or entity layers. That's where we were talking about every single layer should have its known request and response objects. And so this translation of that data between those layers, that's where this would happen, these interface adapters.
Yeah, and now we're on to frameworks and drivers, which is basically the bottom of this cone here. These are the lowest details things. These are the websites, the devices. These are the glue that hook up the various. Oh, wait, what? Did I skip something? I started saying something that's different from the notes.
I think what we're trying to say is these are the glue that hooks up things. So like this is like an example is SQL Server. You're not writing much code in this particular layer, right? We use SQL Server, but we don't write it. We use or IIS, but we don't write those things. So we're hooking up like IIS to the rest of our application so that it can be served up. And similarly, like we're setting up SQL Server so that it can serve up the data, but we're not really writing SQL Server itself, right? We're not writing Apache itself or IIS or, whatever.
And this is where the inversion stuff would happen too, right? Because it's like the entry point into your application to a certain degree. So if you have a website and you want your UI and your business layer to utilize data from a database, then you're probably going to inject your SQL calls. Like you're going to create those classes that call to the database, and you're going to pass those up to your business layer so that the business layer can just say, hey, go get me, account data, or go get me customer data or whatever. So this is why it says this is where the glue is. This is where the inversion happens.
No. That's the adapter though. What you're describing is the adapter. This frameworks and drivers. These are like all the tools that we're using. These are the lowest level tools that we're using. We're gonna run on Apache. We're gonna run on Apache. We're gonna use Oracle, and we're gonna configure Apache to serve up our application, and we're gonna configure Oracle to serve up our data. Like that's the gluing that's being done. Because he makes the point, like you're not writing code in this section, and in this, what you described, you are writing code, and you're writing a decent amount of code to do that part, right? That's the interface adapters.
Okay.
Yeah, I got thrown off when I saw the word glue because when I saw glue, I immediately started thinking like, wait, that's how we connect layers with glue, right?
Right.
But not the case.
I think that's where, and this is where, by the way, I've gone looking for code examples on how he's done this stuff, and I'm going to continue to look because I would love to come back to this because
this layer are the details that don't matter. These are the details that we defer. Which web server we're going to use, which app server we're going to use, which database server we're going to use. These are the details that we're going to try to defer for as long as possible. And we will eventually wire them up, right? We will eventually install something, configure something, and use it, right? But we're going to hold off on that decision for as long as possible. That's what the frameworks and drivers section is.
Okay.
Yeah, I think I got hung up here because I kept thinking like, okay, well, where's my website then on this chart? And it's like, oh, well, it's not really reflected here because it's got use cases, it's got controllers, it's got ties into database and web here. This isn't a drawing of those sort of things. This isn't a component diagram. This is a layer diagram.
Right. The one above it is the one like where the controllers are. That's what's going to do that kind of stuff. That's correct.
Yeah.
All right. So then we have this whole notion of crossing boundaries. So this is when they talk about the flow of control went from the controller through an application use case and then to the presenter. So they had this diagram that shows this. And what they're trying to show is from going between the layers. It starts in the controller, which was in that, not the bottom layer, but the one just above it. It goes from that. Then it goes and calls into a use case, which is up in that second layer, the one that's not the entities at the top, but the one below it, calls into a use case, and then that brings stuff back out into the presenter. So that's where it shows it moving up the chain and then coming back out and hooking that data in.
Yeah, and once again, we're coming back to dependency inversion. We want those source code dependencies pointing in towards the use cases, not the other way out. We don't want those use cases to have ties into that outermost layer. So that's where we're going to get around that with a dependency inversion, injecting those things in there one way or another.
Yeah, I tried to spell this out here. I don't know. Let's see. So you have a use case, which is your second layer, right? That's not your top one, but that's the one right below your entities. It needs to call a presenter. But you can't do that because your upper layer cannot call your bottom layer, right? It's not allowed to reach down and know about those implementation details. So they can't know about those outer circles. So the use case would then need to call an interface. It would basically have some sort of interface that it knows about. The implementation of that interface would be provided by the outer layer. Or maybe in the case that you were just talking about, not that most outer layer, but that second one where the controllers and all those things live, that would be provided from there.
The interface adapters.
The interface adapters. And that's how the dependency is inverted. So you have this use case that's depending on encrypt. We'll call it iEncrypt, right? It doesn't know what is actually going to do that. It's just going to be past something that fills in that contract. So that controller is going to pass in, let's call it a SHA-256 encryptor.
No, wait. No, let's not confuse that, because in that case, encrypt was our entity.
Yeah.
So our use case was going to be to take in like a reader or a writer. So the reader or writer, no, because that had to be at the entity level too.
What was the thing? Set up a customer. Let's say set up a customer as a use case, right? Set up a customer. Okay.
So iCustomer.
iCustomers are going to come in, or iAccount, iNew account, something, whatever. It doesn't have any implementation that it can use, but it's going to be given an iCustomer object from down in the controller. And so that controller is going to be what knows what kind of iCustomer object to create, be it a factory or some other type of mechanism, and it's going to give it to that use case layer. And that use case layer is going to be like, all right, I have this iAccount object now. Let's call .create on it, right? So iAccount.create, if everything passes, it doesn't know about the implementation. It's just going to let that stuff flow back out. And I think that's inversion of control is literally, again, you mentioned earlier, it doesn't have to be an interface. It could have been an abstract class. You could have had a base account, right? Or something that polymorphism is affected by. Is
dynamic
really what
polymorphism.
Man, and you know what? That's something that I honestly feel, I don't know about you guys, but I feel they did such a disservice in school. Is the whole talk about polymorphism was centered around making objects conform to it. But they never gave you a good reason why, other than, hey, it's a roadmap. Like, that's literally the answer I was always given was, oh, well, you want, if there's a click event that's available, then everything should have the term click event. And I was like,
Right. It's about attaching behaviors to things. It's like, oh, just implement stuff so you get work for free.
yeah.
Like, no, that's not really what that's for.
That's not the purpose. And that's really where, like, if you want to take polymorphism as what it's very useful for, it's this. It's literally being able to flip things on its head and say, okay, instead of me dictating what's going to happen, how about you tell me, here's the thing that you want me to use, and I'll just use it because I know how to use it, right?
Mm-hmm. I mean, one case that I was thinking about this, again, in that use case example, that interface for the iCustomer is going to sit, the definition of the interface is going to sit next to the use case in terms of the levels here. The implementation of the iCustomer interface will exist below that in that adapter interface or interface adapter level, right? And instead of, one advantage of using the interface instead of a concrete class would be you could kind of have a little bit more control over like how something has happened. So maybe if you wanted to say a name property, maybe it just returns back a string as it is, or maybe it does some kind of computation to say like, oh, you know what, I'm actually going to concatenate all of the, the first name and the middle name and the last name with a space in between, and if there's not a middle name, then I'll only have one space. Right, like so, it's making those kind of decisions, right? Like that's an implementation detail in that interface adapter that is deciding. But because you only had an interface, you had a little bit more freedom in how you decided to make that, right? At least like in a C# world, because you could have that interface define name as a property, and yes, technically behind the scenes, it's going to create a method the same as what you might have to do in a abstract class equivalent. But at least from the syntactic sugar, it's not going to look like that. It's just going to look like one is just a simple property, almost like a variable, when in reality it's not. So, data crossing the boundaries. This is getting into the areas that I was describing before about the DTO. So, typically, data crossing the boundaries consist of simple data structures, which I keep referring to as DTOs.
Or POCOs or POJOs or...
Well, yeah.
Well, a POCO has behavior though, right?
That's like a POCO or a POJO. I mean, that's a plain old Java class or a Java object or a plain old C# object, right? And I mean, when you think of those, then when you think of a class, you typically think of something that has behavior, right?
Right.
So this is where I guess it gets to be a little bit, I don't know, maybe it's a holy war, but I've definitely had disagreements with people where I'm like, no, a DTO is just a simple data transfer object. That's when it's just data only. There's no behavior to it. When I think POCO or POJO, I think like a class, an object that can have behavior to it. But that's irrelevant, at least to this point, as far as the data crossing. The point is that these are simple data structures. So if you're in like a C world, for example, it could just be a struct, right? That you're passing back and forth.
DTO is more appropriate. Just looking at what some people define it here, it's a DTO is a class representing some data with no logic in it.
Right.
That's what we're talking about.
Yes.
A simple class. It's a bag. I've heard it as a bag of properties.
Yep.
That's essentially what you've got.
Yeah, I just think that difference, the only minor difference is just that it's intent. It's intended to be used to move data.
Yeah.
So I don't think that's a real important distinction. That's the only difference between that and POCO. So if I say DTO, like I'm generally meaning that this thing is going to travel.
Yeah. So, but the point here I'm trying to make though is that going back to the C example, like it doesn't have to be an object at all. It doesn't have to be a class. It could be a struct, right?
Right.
It's just as it could be a JSON object. It's just some data that you're passing back and forth. God help you if you write it in XML.
Right.
I curse you.
I can validate it.
Oh,
right. Everybody uses DTDs.
Right. So this goes back to the conversation we had before about like not passing the entity objects, right? So or the data rows back and forth, right? So entity objects would be like passing entity objects would be coming from the center of the circle out or the data rows would be going the other direction, coming from the outside of the circle inwards, right? Or if you think back to our cone examples, the entity objects would be going down the cone towards the ground, and the data rows would be coming up towards the tip of the cone.
Ziggurat. Yep.
Yeah. or that made up word that Joe keeps saying.
A wedding cake. Okay.
That's like the ziggurat.
Okay.
Okay, I got it. I know what you're talking about. You're talking about like the Mayan looking pyramids, right?
Yeah.
I got you. All right. I'm there. All right. The ziggurat.
Yeah. So ideally we don't want to pass those around, because then we are leaking a dependency if we do that. And we want to keep those dependencies isolated.
But I'll approve.
Like earlier.
Send me that pull request.
You won't.
Yeah. No, he will.
Like, don't do it. You can do it. Don't do it.
But if you do it, just know that you're going to violate the dependency rules we've described.
Yeah. So don't do it. Do it.
Don't do it, but get it done and just go ahead and do it.
Yes.
No, don't do it.
Do it.
All right. So data is passed in the format that is most convenient to the inner circle. So if you are in the use case ring and you're trying to pass data to the entity, then you're going to pass something that the entity knows about. And this is where I was coming up with the idea of like, okay, well, that means that the entity has to define the interface. It doesn't implement it, but it defines the interface or the abstract class that it expects the data to come in as, right? And similarly, from the use case, ring, if it's coming from the controller, then the controller is going to pass the data to the use case in a way that the use case knows, and that means that the use case has defined the interface that it wants to be met, right? And these data structures, these are simple, they're isolated, they stay within their level. So this goes back to, I think Joe made the point about like, hey, if you have these 4 layers, then you end up with these 8 request response models, one per, for each layer. Does that make sense?
Yep.
And when passing the data, I already said that. It was in the form of the most convenient. So this is where it comes back to, again, the DTOs, our DTO, this means that our DTOs, when crossing the boundaries, they belong to that inner circle. Like that, going back from if the entities is the most center circle and use cases is a ring outside of that, then the entity knows the DTO. It has that definition of it.
But it sounds like each layer would have its own set of DTOs.
That is my
request and
understanding.
response objects. And then to marshal things into a more abstract class, the lower level class, the one that is more detailed or closer to the inputs and outputs, is going to know how to translate that data into that upper or inner layer.
That is my understanding.
Yep.
Each layer would know how to do the translation to the next.
Yep.
And the thing that works about that traffic cone example, again, like I kind of described this before, was that when I said the cone touching the table, like that it touching the ground is an interface, right? So like only the bottom part of that cone, which would be the outermost ring of the circle, knows the details of touching the ground. Is the ground wet? Is it mud? Is it concrete? Is it tar? Right? Like as an example.
Yep. Yeah. It's, again, I think when we started all this, there were a lot of things that were thrown out in terms of statements that they weren't clear, but I'm thinking, at least along the way, I know when I was reading all this, it started becoming a lot clearer.
Oh yeah.
As he got into all these ones. And I mean, we've talked about a lot of stuff. I mean, we're 2 hours and probably 15 minutes into this. So, hopefully this is all making sense.
I mean, like I said, just reading this book has given me a much stronger understanding of domain-driven design.
Yeah.
Which, I mean, that seems crazy.
Yeah.
One book helped you understand the other.
I think at the time we even said that we wanted to go back and reread domain-driven design after getting late in the books. Like, okay, I'm starting to kind of get it. Let's go back.
Yep. And so wrapping up this one of the things that he points out at the end of this particular section was conforming to the rules is not that difficult, but it does require you to mentally take it on, right? Like you have to be thinking about it as you're doing it. And if you do that, if you take the time to do it, then it'll set you up to be able to plug and play these things as you move along, which may not sound like much until you decide that, hey, my site's slow because my database is slow and we need to be able to plug in something to make it faster, right? Like having those separations can really pay off dividends in the future with smaller pains.
And because you're removing dependencies from the layers, then it makes things more testable.
Yep.
We've talked about testability being easier to maintain. It's more bulletproof. You feel more comfortable making changes, especially big changes, because you have tests to back up whether or not what you did worked or broke something.
They give you confidence.
Yes, that's the word I was trying to look for. Thank you.
Yep. So that basically wraps up those sections here. I think we have a show summary, so we'll do that later. So
this chapter actually like pretty much sums up the whole book. I feel like it really ties in all the advice, kind of brings it all into one spot into like one chapter. So if you only read one chapter in the book, I would say read this one, then kind of dive in as needed.
Your way back. Yeah, this did really kind of tie a bow on it. So obviously one of the resources we like is Clean Architecture. And don't forget, if you've made it this far, that we do have a contest on this one. So if you go up there to this episode 75, and leave us a comment on there, you can be entered for your chance to win your own paperback or Kindle version of the book. And
I'll tell you, Uncle Bob is a lot more eloquent and well-spoken and organized than I am. So if you like what I had to say about it, you'll love Uncle Bob.
Yes. Oh, man. All right. So with that, it's my favorite part of the show, and that is the tip of the week.
Yeah, and I'm going first here. I wanted to mention a kind of a problem that I ran into the other day sending some emails. Had a real weird issue where certain email clients weren't getting image embeds. If you've never done image embeds before, the concept's really simple. You basically send an attachment, but then you kind of tell the email like, hey, listen, that attachment, it really goes here. It's an image. And there were a couple problems with it, but the main ones I was dealing with was actually on the iPhone and Mac. Actually, Outlook on both of those guys was being weird, only on like iPhone and Mac. And so I thought it was this, I thought it was that. I tried a bunch of different things, and it ended up being the stupidest problem in the world. I had a MIME type with a period in it, which I know is wrong. It wasn't intended. It was just a bug, but it worked everywhere else, but not in these very specific things. And actually, when I read into it too, I happened to notice that the MIME type for JPEG is JPEG, and it doesn't matter which extension you're using. That's always the correct the MIME type. So I don't know if there's any good MIME type libraries out there. I'm sure there's like NuGet package if you wanted to bring that in, or an npm package or something. But I just thought it was kind of interesting. And if you've never dealt with MPEG with MIME types before, it's basically just a way of kind of classifying your data and saying, hey, this is a bitmap image, or this is a MP3 file or something. There's actually a big list of like, I think it's ISO standards of what all the ones are, but you can't take it for granted that's just going to be the file extension. And you definitely can't include that period.
Nice tip.
All right. So for mine, I'm going to give a Team City tip here that I ran into, where I discovered that if you, let's say you have a Visual Studio solution that contains a lot of projects, and you only want to compile certain projects within that solution at a time to, maybe have like you want multiple configurations, and each one is just targeting a specific project, so that you don't have to build necessarily the entire solution, but only parts of it at a time that you care to build. Within Team City, you can set your target to be the project name, and then do something like build or rebuild or clean or whatever. So you could say, like, say you have a project that's called My Project Name. You could say My Project Name : build, and it'll target just that one project name and build just that one project out of the entire solution. And you might have like 100 projects total in that solution, for example. But here's where the real problem came in. With that, in my case, I had a project that had spaces in the name. So it was my space project space name, and I wanted to build that. So thanks to our amazing Slack community, what I learned was if I did my percent 20 project, percent 20 name,
It's funny.
build, then Team City would properly build just that one project out of the entire solution. So it was crazy weird. It's not like I had to double encode the percent, but I basically had to escape the percent with a percent. So that's how that worked. But I wanted to say thanks to the Slack community, Crittner, Sean, Robert, and Azteg that helped me figure that one out, because I was definitely stumbling on it, and big thanks to them.
Awesome. Yeah, our Slack community is awesome, truly. All
Yes.
of them.
And if you're not a part of it, you should definitely join. You can head to www.codingblocks.net/Slack.
Man, what are you listening to over there?
Yeah, what is that? Are you playing a game?
No? Do you hear something?
You lie.
Yeah.
You lie. All right. So,
What game are you playing? Maybe we want to play.
yeah, exactly. All right. So
I don't understand. Is it my phone? Anyway, we'll figure it out. Did it just start?
you really don't hear it? Whatever it was, it sounded like almost
It's
like
still
a
happening?
character. No, not now.
Yeah, I definitely heard he was definitely cashing in something, because you'd hear the register ring every now and then.
Yeah. Anyways, all right. So mine, actually, I have a few here. Two of them are basically the same. So with this whole abstraction
All right,
thing,
you get one. Pick.
No, I can't do it, man. These are like a state of consciousness. As soon as they're gone, they're gone. So one is the common logging abstraction for .NET. It's a NuGet package. I have a link in here, but it's really nice because along the lines of what we were talking about, you don't want to leak your implementations all the way into every layer of your thing. And the common logging abstraction allows you to just have interfaces and abstractions that you can include in your projects. And then whichever logging framework you want to choose, whether it be Log4Net. Oh, wow. There's one that you mentioned recently that was pretty good, Joe, that you said has been getting a lot of attention.
Oh, yeah. I forget now. Serena, something like that?
Yeah. There's other ones, Nlog, whatever. But the key is here, you can just include the interfaces, the abstractions, and it will work. So like that, my buddy Will Madison had mentioned SLF for J previously, back when we had talked about this a while back, and that's an abstraction in Java for being able to do the same type thing. So have a link for that one as well. And then the other thing I want to say is, so I think it was the last episode, I couldn't take it anymore. So we had the paperback version of Clean Architecture simply because that's all that was available when we started reading the book, if you guys remember correctly, some 20 years ago. And I couldn't take it because I'm typically reading in the dark and I don't like having lights and stuff over me. And so I bought it for the Kindle, which was awesome because I could read it on my Kindle. And then when I was going to do the show notes the other night, I was like, wait a second, I don't need my Kindle next to me. You can read it on the web. So in case you didn't know, you can go into your Amazon account. I mean, a lot of people probably do know, but if you don't, go into your Amazon account. There's a section under the pull down over there where your orders and stuff are, and there's a place for content. You can go see all your Kindle books in there, and you can say, open it up and read it on the web. So you can have it as another tab in your browser. So if you're wanting to read, do some research or whatever, you don't have to have multiple devices sitting around to do it. So that was my other tip.
Well, you can also go to read.amazon.com.
See,
Is that
not
what you're
everything.
describing?
No, not everything works there, and that's what's frustrating. I've tried that in the past. Some books won't load up on read.amazon.com. Why? I have no idea. But this one does. I have some books that didn't, but the one that, it did open it up in read.amazon. Okay, so no, I take it back. You're correct. So I used to have books that wouldn't open up there. Read.amazon.com. We'll leave the link there.
Oh, wait, you removed one of your things because I had a note.
Did I?
Did I accidentally wipe over it? I pasted the link in for Seralog, which is the logging but I might have deleted something.
I thought you were going to talk about email addresses.
Oh, we were going to mention that too. Okay, so this one is sort of just a random thing that we were going to discuss because we started to before the show, but it might be useful. So I brought up one of my tips was going to be, hey, if you have in your application where you're having to take in email addresses, a lot of people would just say string email and then have some sort of regex validator that they run against it that they copied and pasted from Stack Overflow, right? There's another way. There's a C# class called mail address, and I think it's in the system.net. I don't remember what anymore. Here, I can tell you right now the namespace. It is system.net.mail namespace, and it's called mail address. And this is a way that you can get validation, but it also breaks things out to where you can create an email address that will give you back a host, a user, a display name, and an address. So, and you had thoughts.
Specifically, what you were going to say was that if you wanted to use it as a way of verifying an address, if you try to pass in a string to it, it'll throw an exception if it's not a valid format. So basically, it was like a cheat to use that thing as a way of knowing whether or not the input was a valid email address or not.
Mm-hmm. So even if you don't want to send the email, you just like new one up and see if it fails instead of saying like mail message.validate or something, because there isn't like a validate method. You just create a new one and see what happens.
Yep. And if it throws, then you're good. So just try catch the thing, new it, and you've got whether or not it's a real address or not. So pretty cool.
So one of the things that we were talking about was like, okay, if you were going to, how might you do this if you were going to write it like, kind of where you were coming from is like a lot of people just take the, well, I can do this myself kind of path, and they'll try to write their own regular expression or something similar to that, right? Now, have you ever seen the official spec for that?
You mean the properties, constructors, all that? Or you mean for an email address?
For validating an email address.
Oh, yeah, it's ridiculous.
So,
and almost nothing does it right.
I'm going to see if I can get this thing to cooperate with me here. If I can do.
Funny story while you're doing that. I had one of the VWs in the buyback program for Dieselgate, right? And typically when I sign up for any kind of service, I usually use my Gmail plus and then whatever the name of it is. So it might be my email plus VW, and that's because Gmail will allow you to do a plus, and anything that you put after the plus will still get routed to your email account, but now you can set up filters for it, right? Man, I can't tell you how many times that's caused me a problem over the years, because what you're probably about to show is most people don't do email validation properly, and on top of it, they don't encode them properly. So if they're doing GET requests with them, then that plus doesn't come in properly and it jacks up requests. I literally had to go in and hack the VW claim site to make my thing work because I used that email address. I had to troubleshoot the problem to a person on the phone and be like, yo, this isn't working because of this. Will you please go in and do X, Y, and Z?
So here's the thing. The spec for RFC 5322 is insane, and you are insane if you decide to write your own. You really shouldn't, and that's why you should use something like the mail address class that Alan was describing. So the worst offending one on here is definitely the Perl implementation. If you were to try to write a regular expression, and this only works, this says 99.99% of the time it'll work. That's how crazy the spec is for it. How many characters do you think the regular expression is for Perl?
I feel like I knew this, but
no, don't look it up.
No,
I have no clue, man.
I'm going to give you a link in a minute, but
oh my, no way.
Oh man, you looked.
I couldn't help it.
You're like a little kid, man.
That's ridiculous. I can't.
Right, well,
I'll put it like this. I can't even count it.
I'll go ahead and share it with Joe here. Where's Joe at? There you go, Joe. Now you can see what we're talking about. The Perl regular expression to somewhat verify an email address most of the time is 6,499 characters long. And that's why you shouldn't try to roll your own.
Man.
And even then, it's only 99.99% of the time going to get it.
There is no 100% solution, is there? It's basically just send an email, see what happens.
Pretty much.
Did it bounce? No.
Right.
Okay. Yeah, man. That is insanity.
Right. So if you think you got clever and you wrote like a regular expression in your JavaScript that was like,
let me tell you, if you check for some stuff and then an at and some stuff and a dot and some stuff, like you're going to get 95% of the way there.
But you don't even have to have a dot in that last one, do you? I can't remember.
Maybe not, but you're going to handle.
Yeah.
I'm going to say that 99.9% of email addresses do. I mean, don't definitely use the library. Don't get me wrong. Absolutely. But maybe.
Matt, I'm telling you. No, just
don't do this, but if you're going to do it, but don't do it. Go ahead and do it.
We'll approve it.
Yeah. So yeah, definitely don't do it. But it's funny that it's so complicated, but I feel like all three of us could easily look at, just about every email address we've ever seen in our lives and been like thumbs up, thumbs down with 99.9% accuracy.
That's funny. You're probably right. Although there are some obscure rules that you just don't know about.
If I go look for obscure email addresses, then I'm sure I could find some.
Yeah, man. So at any rate, the mail address class. If you didn't know about it and you do .NET development, C#, VB, whatever, be aware of it. It could help you out.
Yeah, and don't be that person that has the weird address. Don't do it.
Yeah, Alan.
Hey, man. I just tried to leverage what Google gave me, man. That's all I'm doing.
With a weird address.
The plus sign. I just leveraged it.
All right.
So yeah, we've covered a lot in this show. We're not gonna go over it again. We went over it a lot.
We're all
we talked about stuff.
Yeah.
Screening architecture and use cases and policies and crossing boundaries. And so stuff. And with that, we ask that you subscribe to us on iTunes, Stitcher, and more. Use your favorite podcast app if you happen to be listening to this because a friend might have pointed you to it or whatnot. And be sure to give us a review by visiting www.codingblocks.net/review.
And while you're up there, check out all our show notes, examples, discussions, and more.
And send your feedback, questions, and rants to the Slack channel at codingblocks.slack.com. And be sure to follow us on Twitter at codingblocks or head over to codingblocks.net and you'll find all our social links at the top of the page.
That was a short episode, guys.
Yeah.